Hello students, welcome to my YouTube channel. In this video lecture, we are going to continue solving or answering the next 10 questions from this ILS chapter, Keith Williams Radio Lab. Let's begin with question number 91. Now, question 91, 92, 93, 94 are all based on marker beacon. So I have clubbed them. So let's do one by one. The ILS middle marker modulation frequency. So they are talking about, or they have asked us about the modulation frequency. Now, when we discuss marker beacons, there are two frequencies you must remember. The one main carrier frequency, which is 75 megahertz, and the other is modulation frequency. Now, this modulation frequency will be different for each of the three marker beacons. For the outer marker, the modulation frequency is 400 hertz. For middle marker, it is 1300 hertz. And for the inner marker, it is equal to 3000 hertz. Okay. So, middle marker modulation frequency is Charlie, 400 Hz. Inner marker beacon of an ILS transmit at. So now here they are talking about transmission. That means the main transmission frequency, which is VHF 75 megahertz. All the three marker beacons, okay, transmit on the same VHF carrier frequency 75 megahertz, but the modulation frequencies will be different for each of them. So inner marker beacon transmits at 75 megahertz. All ILS marker beacons transmit. Now again, transmit. That means they are talking about transmission. And all marker beacons transmit at the same VHF frequency, 75 megahertz. Middle marker beacon of an ILS transmit at what? Again, they are talking about transmission. So the middle marker beacon transmits at 75 megahertz VHF. Next. ILS produces a radiation pattern which is amplitude modulated by VHF frequency of the ILS, a radiation pattern which is amplitude modulated by 90 Hz and 150 Hz signals, two lobes modulated in frequency by 90 Hz and 150 Hz, a 90 Hz lobe, a 150 Hz lobe which are amplitude modulated by the VHF frequency of the ILS. So here the correct answer will be option Bravo. This ILS instrument in the form of localizer and a glide path transmitter transmits on a fixed frequency, and this frequency is for the amplitude modulated. Now this radiation pattern consists of two lobes, 90 Hz and 150 Hz. Similarly for glide slope, 90 Hz and 150 Hz. Okay, so they are modulated by 90 Hz and a 150 Hz. So option Bravo. Next. ILS receiver of aircraft on approach flying on the right side of the exact runway center line will receive what? So this is your localizer transmitter on the opposite end of this approach end of the runway. This localizer transmitter or localizer aerial will transmit this 90 Hz radiation pattern consisting of 90 Hz lobe or 150 Hz lobe. Now when you are tracking exactly the center line of the runway, you will receive both these signals, that is 90 Hz and 150 Hz signals, equally. Okay, so the difference in depth modulation will be 0. Let's say you deviate to the right hand side of the center line, somewhere here. In this case, you will receive more of 150 Hz signal and less of 90 Hz signal. Okay, so in this case, the difference in depth modulation will not be equal to 0. There will be there won't be any balance between the 90 Hz and 150 Hz lobes. Okay, so what will happen when you deviate to the right hand side? First things first, the difference in depth modulation will increase. Okay, and when you deviate to the right hand side, you will receive the right hand side tone or lobe at a much more than the lobe on the left hand side. Okay, so the left lobe modulation only, wrong. The modulation from both lobes at equal amplitude, that won't be the case because you have deviated right hand side. A modulated signal and will shift the localizer needle to the right according to the magnitude of the difference between the two amplitudes. More of 150 Hz signal than the 90 Hz signal. So option delta. An ILS approach when flying overhead the middle marker. What is the color? Okay. So when you are flying overhead the middle marker, the color that you get is orange color, amber color. For outer marker it's blue. For inner marker it is white. So the correct answer here is Option A, amber. 98. On an ILS approach, when flying overhead the middle marker, the color again, same question. So you are flying overhead the middle marker, and the color you get will be option delta, amber color. Next. A VOR, very important. A VOR is situated at the far end of the runway on which aircraft is making an ILS approach. Nav1 is switched to the localizer frequency. Nav2 is tuned to the VOR frequency. At the moment that the needle of number 1 indicator reaches the outer dot, the deflection needle of number 2 indicator will be where? Okay, so nav1 is localizer frequency. So we will be having two CDI indicators, one for localizer, second one for VOR. Fine. So nav1 is switched to the localizer frequency. Now they say the number 1 instrument, which is the localizer instrument, it reaches the outer dot. Okay, reaches the outer dot. Maximum deflection has happened in that particular indicator. So let's say this is your 5 dot indicator, 2, 3, 4, and the localizer needle has reached its maximum deflection, left or right, whatever. So at the extreme end, somewhere here, like this. Okay. Now, this is your VOR equipment with a 5 dot indicator. So over here, in case of localizer, 1 dot will be equal to zero point 0.5 degrees in case of 5 dot indicator. Okay, so 5 dots will be equal to how much deflection? 5 into zero point 0.5, that is equal to 2.5 degrees, right? Now, so that means the deflection is equal to 2.5 degree. In VOR, this 2.5 degree will be represented by how many dots? In case of VOR, 1 dot is equal to 2 degree. So 2.5 degree will be represented by how many dots? It will be represented by cross multiply 2.5 divided by 2, which is equal to 1.25 dots, that is 1/4. So the correct answer will be somewhere here, like this. Okay, so 1 dot, 1.25 dots. So the correct answer here will be approximately a halfway the scale, the outer dot, approximately 3/4 of the scale, approximately a quarter of the scale. Option delta. An ILS approach, when flying overhead the outer marker, the color of the flashing light will be what? So when you're overflying the outer marker, the color will be equal to blue color. So option alpha. Simple. So this brings us to an end of this lecture. I hope you have understood all the 10 questions. Very easy questions. The 99th question was a little tricky one. But if you know that in case of ILS localizer, 1 dot equals to zero point 0.5 degree, and VOR, it's 1 dot equals to 2 degrees, you will be able to answer that question very well. Okay, so it's a little bit tricky, but not very hard. So pay attention to solve that particular question again, and be ready for many more questions, many more surprise questions like that. So in such situations, don't lose your calm, uh, be positive, and try to recollect the theoretical knowledge you have in memory, and also try to work out possible options. Okay, but don't give up. All the best. In my next video lecture, I will solve the next questions remaining from this chapter. See you.